Today we'll begin with the first tool in our course, which is a GIT, a version control system in Git. So let's learn about like what is a version control system, why do we need version control system, where do we use it, the architecture and so on. So let's get started. First, let's begin with what is a version control system. To understand this, let me take a simple use case. Assume like there is some project, right? A team of people are working on it. And all the project work, all the data is present on some remote location. Like let's assume like we have some bunch of files kept over here, like file 1, file 2, and so on, right? A bunch of files available here. Let's say there are multiple people working on this. Like there is a person A working on these files as well as person B, right? Assume that person A want to make the changes to his file and he got the file to his local computer. Like he downloaded this file to his system. Even B also got this file to his system and they were making modifications. Both of them were working on the same file, and let's say person A kept the file back to this remote location on day 1. Let's say he put this file back on day 1. And this person B kept the file back on day 2. Now let us see the changes on this file 1. File 1.
Preeti, excuse me, Preeti. The background is not black. It's actually in the background we can see what is VCS, and then we are not able to see properly what you're writing.
Yeah, background is the presentation I'm sharing. Just give me a second. I changed the color. I couldn't change the background for now. I'm just changing the color. So here, both the people are making the changes. After day 2, the file is having which person changes after day 2? After day 2 on remote, file 1 will have which person changes? Yes.
Can you please come again, Priti? What is the question?
Okay, let me repeat the use case. There is some folder, okay, a shared drive kind of across the team. There are two people, person A and person B. Okay, both of them want to make changes to file 1. Both of them got this file to their local system, made the changes, and A kept the file back on day 1. B kept the same file after making the changes back to this shared drive on day 2. Now, after day 2, like with this manual approach, without using version control system, this file 1 will have which person changes after day 2?
It's person B.
Person B, actually, last one person.
After day 2, this will have only person B changes, right? Means what is happening here? Person A changes are being overwritten by person B, correct? It's overwriting here, overwriting. Person A changes are overwritten by person B changes, correct? This is happening without knowing. B doesn't know that he is doing this. Even A doesn't know that his changes are being overwritten, correct? So this is happening without knowing each other. If this keep on continuing, imagine a team of developers, a team of 10 people. If this keep on continuing, the project goes corrupted or messed up. Am I correct? So how to handle this, how to deal with? That's where comes version means that's one of the use cases where version control system comes in. Version control system allows multiple people to work on the same file parallelly. It will allow multiple users or multiple people working on the same file parallelly. Correct? So we need a system which can do this, because if everyone is making the changes and updating the changes, we don't have a control on what changes are overwritten, what changes are being ignored. So we need a system which can handle these changes, which can help save these changes, or which can help have a track of which person is making changes to what, right? So this is possible through version control system. Not only that, this can help you with a detailed logging. Means which person did what. Let's assume application is working fine today till 7 o'clock. Okay, 7 a.m. application is working. From 7:30, application is not working fine. Application went down. We need to immediately bring the application back. This means we need to know what changes happened during this 30 minutes, right? So we need again a logging which can help with all the details, including the timestamp. Means like person A made changes to file 1 on line number 7 at 7:15. So if you have this kind of detailed logging with the timestamp, it would be easy to revert those changes and bring the system back. Is this possible manually? If you don't use any version control system, is this possible manually? Right? So this is again handled by version control systems. Another use case where version control systems comes in. Or else let's say, okay, there is some file 1. It's a version 1. Right now, client came with some modifications on this file 1 and they want a new version 2 of this file. Let's suppose you have modified this file and made it version 2. Like you made all the changes. After 6 months, client just want to go back to the version 1. Right? Because the new version is having some drawbacks or it's not working for them. They just want to go back with the previous version. But you have overwritten those changes or edited the same version and made this version 2. So if they want the previous version, again, you have to rework. Correct? You have to rework to make to revert the changes and put the version 1. Right? So this is again without version control system. You can use version control system which can help maintain these versions. Right? You can, means instead of just editing the same file, you could have maintained versions, maintain the backups, maintain the versions. All of this is possible again with a version control system. Version control systems can help you with maintaining versions, backup of the files. It can help you with a detailed history of what changes went at what time to identify and revert back in case needed. Or it allows multiple people working on the same file at the same time. All of these are possible through version control systems, right? So, and like where do you use it? It can be used for any files. Any project files can be version controlled. It's not specific to a particular programming language. It could be Java files or C# files, Python files, Perl scripts, or even test scripts. Any script files or even test files, text files can be version controlled, right? So anyone can use it. Developers, it's mandatory. Even for testers, it's mandatory. Now they were using automation testing. They do write automation scripts. Definitely, they'll be using this version control systems a lot. Even ops teams uses it to manage their script files, configuration files. DevOps team also uses this to manage their files like Terraform config files, Kubernetes manifest files, Ansible playbooks. All of this can be version controlled. So everyone and anyone whoever interested to work in IT should learn this tool. So this is one perspective of learning this tool as a DevOps person to manage your configuration files. Next perspective is from developers. Means, okay, developers might have written the code. They might have placed their code in the version control system. Once they made the code changes, it's a DevOps team who will create the pipeline, which will pull that code from the version control system, build it, and create the pipelines. So that's another perspective of learning version control systems. We'll be learning this version control system from both the perspectives, and we go from basics to the advanced concepts on it. So this is what a version control system will do. Are we clear with this? Any questions in this part from anyone?
Yeah, Preeti, for example, if you, I have a question.
Yes, please.
Yeah, yes, I have a file and I have written some code on the file. I just pushed my code to a source code repository. if I made any changes in that file, again I pushed, you mean to say that it will save as a version control, right?
Yes.
File. Yeah. Okay.
So now that we understood what a version control system is, let's deep dive into it. Version control systems are classified based on their architecture as centralized version control systems and distributed version control systems. So let's look into what a centralized version control systems architecture would look like. See here, this is the centralized version control system. Like you will have a central server or remote repository where all the project work would be kept. And this is the workstation of each individual developer or collaborator. It could be a developer or tester, whoever it is. Everyone uses version control systems, right? If it's a developer, it would be the source code. If it is a DevOps team, it would be the configuration files and so on. So I'm talking about managing the file. So it could be any team. This is the workstation of each individual user. And if you want to make any changes to this repo, you pull the code, get the code from this remote repository to the local computer, make the changes, right? Make the changes here and put the changes back. That's a simple architecture of a central version control systems. But if you see here, there are few challenges. Like first challenge is this needs network connectivity. Let's suppose there is a network disconnected. Entire work is halted, right? You cannot work on it because to connect to the remote server, you need network connectivity. Second thing is, suppose this central server is gone or crashed or lost, chances of recovery are less. Right? Because it works like a single source of truth. We put all the code base in here. So if the changes are lost, they are gone forever. Right? So these are the challenges of a centralized version control system. To overcome these challenges, we have distributed version control systems. This is the architecture of distributed version control system. So if you see here, this is the central server or remote repository, and this is the workstation of each individual user or a collaborator. So the central server or remote repository, here you can see two repositories. This is called as central server or remote server. And this is called the local repository. Local repository, right? If you make any changes, right? Here you will be making changes on this local. From local, you push to remote. Meaning, if you closely observe, every user is having a copy of the central server or remote repository, which is nothing but the local repository. They make changes on the local. Of course, again, they will not make changes on this local. First changes would be made on some other directory called working directory. From working directory, they'll push to local. From local, they'll push to central or remote server. Until they push the changes to remote. Changes are confined only for themselves, right? Only once the changes are completed, they'll push to remote. Here, chances of recovery means, or else first let me talk about network connectivity. You don't need network connectivity. Even though network is disconnected, you can still work on the local and make the changes. You need network connectivity only to push to remote. You push and pull are less frequent because once your complete work is done, you push. To create a copy, you pull. Only for these two, we need network connectivity, and these two commands are less frequent. Most of the times, we work on this local repository, make the changes. Once it is done only, we'll push. So even though network is not there, like network disconnected, you can still continue working on your local, right? So entire work is not halted. And the second thing is, let's say server is crashed or lost, central server. Everyone is having a copy of their remote, right? So chance of recovery are more. It could be recovered from any user, any local repository. So that's how distributed version control systems work. Every user will be having a copy of a remote and they'll be working on their local system. This is how distributed version control systems work. This is the architecture on a high level. We'll be getting into the architecture of Git in particular. Means, yes, Git falls under this distributed version control system. Git comes under this distributed version control system. And SVN, TFS falls under centralized version control systems. Any questions from anyone in this part?
Priti, I have a question.
Yes.
So let's say there are three boxes that you have drawn. So let's say person A, B, C working on working on a file. So we have a local repository, three local repository as per the diagram, and person A works and he keeps the whatever the changes he made in the local repository, and person C, developer C wants to see what changes he has made in the code, and unless person developer A pushes the changes he made to central repository, the developer C cannot access that, right?
See, we'll come to those points, Ashok. Okay, we were just talking about the architecture. We were going to deal with those specific use cases with hands-on. Okay,
Okay.
let's not get into that part now. Just understand the architecture theoretically. We are going to demonstrate that.
Thank you.
And we shall take up this use case again then in a few minutes.
Sure.
So this is the architecture of distributed version control systems. Let us talk about the distributed version control architecture of Git before going to this. Like we discussed yesterday, there were so many tools under each category. If you see here, this is the comparison of Git with other version control systems like Git, SVN, TFS, fossils, and so on. You can see here Git is very widely used. If you see the blue graph, you can see like how widely Git is used when compared with other tools. Do you see here the graphs of others? This is the graph from 2020. You can also grab the latest graph. And all the modern DevOps projects uses Git, like majority of them. Right. So now let's talk about the architecture of Git in particular. Right, like we were talking about, right? There's a remote report, central report, and you get a copy, create a local. Right? Yes, we'll get a local. This is the workstation. This is the workstation of individual users. Okay, and you'll have a local report. Now, you make some changes, and it's not directly you make changes on local repository. Like I said, we'll be making changes on working directory. Working directory is nothing but some folder, some other folder or a directory where you make some changes. And again, it's not that after making changes, you push from working directory. Sorry. After making changes, you cannot just push from working directory to local. No, this is not possible. This is not possible. Then what do we do? Then like how are changes pushed? From working directory, changes will be pushed to staging area. Staging area, what is staging area? You can assume, you can imagine it like another virtual folder, right? From working directory, you will push your changes to staging area. From staging area, you will push to local repository. It's not a vice versa. Means from working directory, you cannot just push to local and so on. That's not possible. First, you have to push to this virtual area called staging area or index area. From this staging area, changes will be pushed to local. That's the Git architecture. That's called Git tree, right? And you might be having a question, why do we need this staging area, virtual layer? What is its importance? It's like a preview or else a pre-check before your changes goes to local. The git add, git commit, git push commands we will learn later. First understand the concept. So from working directory, we'll move our changes to staging area. From staging area, we'll move them to local repository. Right? I told you like this was like a virtual layer which works like a preview or else a pre-check before you move your changes. Meaning, let me take a simple example. Let's say there are 10 files in the working directory. right? You want only 5 files to go into the staging area. So you will add only those 5 files to the staging area. Only those 5 files. And when you commit, all these 5 files will go to the local repository. Means it's like a preview or else a pre-check before your changes goes to local repository. Right? That's a Git architecture. And as long as those changes are in your local repository, no one else can see the changes. They can see the changes only when they push to remote. Once the complete changes are done, changes can be pushed to remote. It's like a 3 steps before your changes goes to remote or others see your changes. This is the Git architecture. Is this much clear, everyone? Okay, let me tell
Yes.
you. Here, local repository. Okay, how do you create local repository? Isn't it? There are multiple use cases for this. The first one is, assume that it's a already project is there on remote. Okay, remote repository is there already. You joined this project as a new member in the team. So already project is there. You want to make some changes. So you copy from remote and create a local repository. This is one use case, right? Copy and create a local repository, copy from remote. Another one is, assume it's a new project. You join this project, you want to make some changes. There's nothing on remote because it's a new project. So you create the repo manually. First, an empty local repository. Create an empty local repository manually. Develop the code changes if it's a developer, or if it's a DevOps person, create your config files and then push to remote. Right? So those are the 2 use cases how local repository will be created. I'll cover both of them. First, we'll get started with this. Assuming it's a new one, we'll get started, we'll begin with this. Right? So those are the 2 use cases how you create a local repository. And another interesting point I would like to tell you. We were discussing like working directories, a folder, local repositories, a folder or directories, right? This working directory and this local repository are like physically one and the same. It's the same folder or a directory. If you are a Linux guy, same directory, whatever you call it, right? It's the same. Then how come you say it's a working directory, local repository? Logically, they are different. Means again, how they are different logically, let's see. Let's suppose I created a copy from remote and created this local. It's a folder, right? Okay, fine. I went inside this folder and I just created a file. Created a file means it is said to be in the working directory only, right? Then later on, let's say, okay, I run the command git add that file. Then it is said to be in the staging area, correct? Then the file goes to the staging area. Means it is again in the same folder. See that box, that's a local repo, that's a folder, right? But when you just create a file, it's said to be in the working directory. When you add it, we say it's in the staging area. Okay, and then when you commit this, then it is said to be in the local repository. Physically, it's the same, but logically, this is how it is different. Means working directory or a local repository, both are one and the same folder. Got it? Understood this logic, everyone?
Yes, Preeti.
If you got some clarity on this theoretically, now we will go install Git and create local repository, and we'll introduce with this local repositories, working directories unknown with a demonstration. Good to go? Any confusions, any questions from anyone? Okay. So now let us install Git. Git works on multiple operating systems. Okay, you have this official page, official documentation, gitscm.com. It's like a reference for all Git queries. Okay, here you have downloads. You can install Git on multiple operating systems. It works on Mac, Windows, Linux. I'll walk you through different operating systems. Let's say you go to Windows. You download the exe and run the exe. As simple as that. You might have known, right? Downloading the executable and launching the executable. If it is Windows, this is how you install. Even in the Google Drive, you have all these steps. If you go to Git folder, Git installation on the Windows, including the screenshot, right? It will take you through the wizard. This is how you will see exe, double click the exe. A wizard will be launched where you have to hit next and go on. This is how you install Git. If it is Mac, okay, first let's go with the Linux. If it is Linux, simple command, depending on the Linux distribution, these are the commands. Anyway, we are not going to Linux now. After learning Linux, we'll come here. Okay, and then if it is Mac also, if anyone using Mac, you have simply reinstall it. That command will do. That's all. A simple installation. So you can use in your local computer. You don't need to go for AWS now. Okay, AWS, using some instance on AWS, will take up this a little later. So you can just go to your system and run this. Like if you have installed it on Windows, go to the start menu and run git bash. Git bash is the terminal where you can run the commands. Or go to the terminal. Right here, like I'm using Mac, so I've already installed Git. I can check the version of the Git. Right, Git is installed. So yes, I can use Git. And I'm using from the CLI. Okay, so here on my desktop now, okay, Git is installed, but we need to tell Git which folder it has to track, isn't it? I might have got my project work in some folder. We have to tell Git which project or which folder it has to track. So create some folder for your project work. I'm using CLI, so I'm using some small Linux commands like make dir, mkdir, the folder. If you are not comfortable with the CLI, you can also use the GUI, like, using a GUI on Mac or Windows, right? Just a second. So you can just go here and create a new folder. This is how you can do. Anything is fine, right? So I'm creating from the CLI folder might have been created. LS will list all the contents of it. See, Git demo is created. You may also check this way if you want. Yes, this is the one. Okay, let's say now I want to Git to version control this folder. Means I'm going to keep all my project work here. Right, all the program files, all the project work I want to keep here. So go to that folder, whichever you want Git to version control. I'm inside the folder. Now, when you go inside the folder, I'm taking the second use case. There is nothing on remote. It's a new project. So you have to create this as a local repository. Whichever folder you want to get version controlled by Git, go to that folder and run the command git init. Git init means initialize Git, start Git, right? When you run this, you can see this verbose and it says .git is created in this folder. It's a hidden folder. So ls -a will help you. You can see .git created. Whichever folder having this .git means it's a local repository. See, this is your Git demo folder. Okay, this is .git is created here, a hidden folder. Means this Git demo is your local repository. I have done Git init. Means it's a way to tell Git to track this, anything present in this folder. Is that making sense? You may also check here. Do you see .git is here? Right? It's a local repository. So, okay, fine. If you want to know what's happening here, you may run the command git status. It says no changes or nothing. Let's create some file and see how Git can track it. Shall we proceed? Good to go? Right. So let me create some file here. You may use touch command to create a file. Here our interest is not to create some Java or something. Our interest, our focus is to manage the file. So I'm just creating some text file. Right. Okay, file is created. Now, can you tell me where is this file? Some time back we were talking about this, right? File is created means, what does it mean? Where is it?
In the working directory.
In working directory.
Exactly. This is the folder git demo. The same is the local repository, same is the working directory. So if I just created the file, means file is in the working directory. If you want to confirm, run the command status. It will tell you untracked, means Git knows there is a file, file1, but it is not tracking it. Right? So for it to track, what we should do? It's not tracking it. Git knows there is a file because it's in the working directory. It knows there is a file, but it's not tracking. It's giving you a clue. Add the file. If I add it, where would be the file after adding it? Where would be the file? I have added it.
It will be in the staging.
Yes. If you see here, changes to be committed, unstaged means unstaged. Sorry, to unstaged. It is staged actually. Changes to be committed means where is this file? Always you have to refer this with your architectural diagram. Whenever you are using it, keep this architectural diagram in your mind. You should refer to this. Changes to be committed means where is it?
Staging.
Staging area. It's in the staging area. Changes to be committed but not yet committed means it's in the staging area. If you want to commit that and put it in the local repository, git commit -m. M means message. M flag is mandatory. Let's say changes on local repo. Okay. So some message. Okay. Then if you see the status, it says it is clean. Means whatever changes are present in your working directory are all present in local. Now the changes are in your local repository. Is that making sense now? Hope you got an understanding how your changes progress from working directory to staging area, staging to local. Are we good and clear?
Yes, Preeti. Is there a way to check what are the files available in the staging repo?
Yes. ls will list the files in your working directory. It's a Linux command, but there's a command called git ls files, which will list the files in the staging area. See file 2. Let me repeat the whole demo with another file so that everyone should be comfortable with. Let me create another file. I just created a file. Can you tell me where is this file 2?
In working directory.
Can I get response from everyone? Where is this file?
Will be in working directory.
It's in working directory. Also, if you see git ls file, see it's not showing you file 2. Do you see the difference? Also, when you do status, see again untracked. File 2 is untracked. Git knows there is a file, but it's not being tracked. What you should do for it to get tracked? What should we do?
Need to add.
File 2 is in the working directory. For it to get tracked, I will add it. So now can you tell me where is the file?
Stage.
Physically, it's in the same folder
Mm.
git demo, but logically, this is how it is different. It is in the staging area. If you want to commit git commit -m, let's say second file or whatever, some message, right? And if you see the status, you could see it's clean. Now, yes, you have 2 files in the working directory, 2 files, both of them in the staging area. So working tree is clean. That's like 2 steps before you push to local repository. Got the flow, everyone? Is this much clear for all of you? Good.
Yeah.
You may, if you are not comfortable with the CLI, you can just go to the folder, create the files. That's how you can do. And commands like git commit, git status, these commands you can run from git bash if it is Windows, or from terminal if it is Mac. Right? So if you are all clear with this use case, I'll go with a simple next example. Let's say till now we created new files. It could be editing the file as well, right? It may not be always creating the file, right? So let's see editing the file. Let's say I want to make some changes to file 1. You can just go open this file this way. Okay, make modifications. Right, this is the file. Let's say hello. I'm adding some line like hello, dummy content, because our focus is not about the content. I just made some change. If you see the status now, see what is the message? Not staged, unstaged. What does it mean? Unstaged means changes in the working directory. Right? See whether Git works with respect to changes. Your change could be modifying the file. Your change could be creating a new file. Your change could be deleting the file, whatever it is, right? So whatever changes you have, whatever changes you are making to the file, like file 1 or whatever, this will be in the working directory. You have to again add the changes. Means what you should do? Let's talk about unstaged changes. Unstaged means yes, it's in the working directory. Again, git add and git commit. Or else what you can do, because it's not a new file, it's already there in the staging area. You can do it with a single command, AM. AM means add and commit. You can do this way because that is not a new file, that's an unstaged change. But you saw some time back a message like untracked. What is the difference between untracked and unstaged changes? Anyone, what is the difference?
Untracked means file is not added to the staging area. Unstaged means
Yeah.
actually file is just created. Untracked means new file.
Yeah, untracked means new file for the first time. It's in the working directory. Here you also you do git add and git commit. But here you can't do this git commit minus AM for new files. Whereas for unstaged files, you can do either ways. But for a new file, untracked changes, you have to do them separately only. You got the difference between unstaged and untracked changes? Now those changes are unstaged, not untracked. Got it right, everyone?
Yes.
Right? So you have to git add and git commit, or else, like I said, because that's unstaged, I could do in a single command git commit minus AM. Let's say file modifications. Some message. Done. If you see status, it's clean. Right? So any change, modification, or a new file creation or deletion, everything will go from working directory to staging area, from staging area to local repository. And these are the differences. And this is the clarity you need to have. What are unstaged changes and what are untracked changes? Right? Okay. And also we were making the commits. We made a bunch of commits till now, right? Whenever you make a commit, every commit will create a commit ID, which is unique, which is alphanumeric. If you want to see the commit history, git log. See, like I run the commit command thrice. So it has created 3 commit IDs. This is called the commit ID, unique alphanumeric ID, including the details like which person made the changes, including the timestamp. We discussed, right? Why do we need a version control system? One of the use cases is to have a detailed logging like this. You know what changes went at what time. If you just want to see a brief log, git log one line. Means you just need first 7 characters to identify it. And then the file, the commit message. See, commit message is very important. Here I'm just giving file modification, second file and all. In reality, commit message is like a comment on what changes went into that commit. Meaning like, okay, in this commit, I made some changes like, let's say we made some changes with Terraform with our EC2. You put that comment so that at a later point of time, it will help you and others to understand what those changes are for. So commit message is very important. It will help you understand what that commit, like what changes went in that particular commit. Understood? So git log will give you the detailed log, git log one line, or else let's say you want to check the log of a particular file. You can give that file name. So 2 commits are done on file 1. So you can check the log of that particular file, or else you can check the log, or else like the commit history of a particular date if you want. Let's say from so and so date, from last week commits only you want to see. All of that are possible. For any command in Git, okay, you can run the help. It will show you, see here, it will show you the complete details this way. Git log, commit, synopsis, description, so many options, what all can be used. See, follow option, no decorate option, right? Source option. Like you can use or you can customize with these options as per your requirement. See, from date, since date, these are all helpful. No, you need not memorize all these flags. No one will memorize all these flags, not required. But as per the requirement, you should know, okay, this is how you can check on the options, sub-commands, right? Any command, you can do that. It's not that you should by heart all of them and all, but you should have an idea, okay, this is how we can check in case we need anything else on a particular command. Another reference is either from the CLI or you can also check here. This is the documentation for Git. See, Git log documentation, whatever we have seen there can be seen. Git log documentation. Synopsis, whatever you saw in the CLI, all of that you can see here as well. Got it right, everyone? That's just a heads up how you can use different options or flags on every Git command. Any questions from anyone? So far we have discussed about like coming to the Git perspective, we have discussed about Git architecture. We have discussed about Git installation, then initializing Git, and then we discussed about the working directory, staging area, and local repository. And these are the commands we have done. Installing Git and then Git init, Git add, Git commit, Git ls files, right? These are the commands, of course, Git status, Git log, brief log. These are the commands we have discussed. Any questions in this part from anyone?
Yeah, Preeti, I have actually.
Yes,
So,
please.
just correct me. What I have understood, like unstage means the file which are existing in the working directory, and we about to commit, right?
About to stage, about to run Git add.
Yeah.
Unstaged commit, untracked commit, both of these are present in working directory only.
Okay.
Both are
So the untracked means we just create the file, but we left it as it is, like we are not taking any action.
Yes, we did not add the file. It's a new file.
Okay, so
And
this unstaged means we have added.
we have added the file to staging area, but then made some modifications. Means file is having some changes which are not added. Just some modifications it has got which are not added.
Okay, but it's still existing in the working directory, right?
Both
Like-
are working directory. Unstaged means file is added to staging area already earlier, but now I made some modifications. These modifications were not added to staging area.
Yeah, for that we have to use the git command commit -am.
Git add, git commit, or else git commit -am, add and commit. Yes.
Okay,
But
got
if it is new
Thank
file, okay, it is never been into staging area, it's a first time, right? You have to do again git add and commit separately.
Yeah, got it.
Any more questions? Let me add the installation commands as well if it is Mac. If it is Windows, download the executable and run the executable, run the wizard, right? If it is a Linux, simple install git. Anyway, Linux we'll learn later, but remember one thing, only the installation setup differs. Once they are installed, the way you work with them is same. The way you deal with them are same. Any questions? And there are many use cases coming up, like we have added the file till now, right? What happens if you delete the file? And how to see the staged and unstaged changes. And when you delete the file, how do you delete from both working directory and local repository? Or how to delete only from local repository? How to revert the changes? And actual use cases we did not start. These are the very basic things. We have to check when multiple people are working, how can it keep the changes? I mean, how can it see that changes are not being overwritten or ignored? How multiple people will work from their local repositories and push the changes to remote. Many other scenarios are coming on. This is just the basic part. We did not get into the actual use cases. We did not go to the remote if you see, right? We were still on local. And what you have to do when you are doing this hands-on or when you are learning it, it is very important you refer this part. Refer to this architectural diagram, which makes more sense of what we were learning. This is very important. And every day, like you will be provided with the class recording. Go through the recording and do the hands-on. First, whatever we did in the class, you have to do that hands-on, which is mandatory. Once this hands-on is done, means like once you have done with this, you can go to the website. Of course, website also have the help with regarding your hands-on on whatever we have discussed. Go to the GitLab assignments. And here you can see installing it, configuring it, creating a sample, everything including the commands with explanation you have here. As well as you have the same on the Google Drive as well. You will be given access to this drive as well as this LMS, the portal from where you can see all the commands, everything for the hands-on. This is for day 2, like where we'll see the different commands, revert and so on, revert, reset and all. This is what we discussed today. Any questions from anyone in what we discussed today? These two things we are doing now. On Amazon Linux 2, we will do after, like before we start Jenkins. Like I said, only the installation differs. Commands, concepts of the tool remains same. Any questions?
So this Git is installed where it is installed on premises or cloud?
On our laptop, we have installed it now.
Directly, huh? No, we are confusing that this Git is being including installed in cloud or on premises. That is my doubt actually.
We will install on cloud also. Today we have installed it on our laptop.
Okay.
And I have shared the quiz in the Google Drive. Like you have got the quiz, you can just go through it now. Every day you will be given with the quiz and the assignments. This is to register and recollect what you have learned. Can you just go through that quiz, go through the link and get started? It's just the basics, whatever we have learned. Go through it and check your learning. Can you all access the quiz page, which I shared? I have shared it in the Zoom chat. Okay, please complete it. You have to log in with your email ID. We will also get those scores. Even you will be receiving those scores and the answers, right? Answers, you can retake the quiz multiple times to revise and register the things. And once you are done with this, right, every day, like on every topic, you should also go through this interview questions. These interview questions are very important. These are not just a dump. These are prepared with the real interview questions. With my experience as I sit in the panel or from the students who have got selected, these are the interviews collected from them. And we have got a very great feedback on this interview questions. Many people got selected and every month we are receiving this feedback who got selected, going through and learning the course from here. Just go through these interview questions as well, like the beginner level, whatever topics we have covered, you can go through these questions on regular basis. So that by the end of the course, you'll be all ready to get into the market. Let me know if you have completed the quiz. As it's the first day, I'm sharing it from my end. Every day you can have, you can go through the quiz from your end itself. From the portal, you can go through the quiz and submit the quiz. But today I have shared it in the chat. Let me know if you are facing any challenges accessing this quiz. And like after the class, we are receiving messages on where to find the link. In the website, if you go to live class login and scroll down, click on live class recordings. Here, if you go, you can see the different batches here. Go to October 24 batch. And this is where all the videos will be available. In this video also will be added to the same playlist and this will be updated. So this is how you can access your class recordings. Any further questions on the batch or the course or any other details, you can reach out to Mr. Raj. He'll be available on this number. Any questions from anyone? We'll be helping you with the resume preparation mock interviews as well for any such career counseling or any.
What is the meaning of the last line? There is some
Sorry?
based on the text above your fourth question. I mean, after the 10th question, there is a one line based on the text above your fourth
Just please
question.
ignore it. Please ignore it.
So I have to put something in. That's a mandatory one.
Just keep your name.
Okay. Okay, done.
All right then. I believe you might have received the score, right?
Yes, I received.
So go through it, check for the right answers, and retake the quiz after doing some hands-on, after going through the recording once again, right? So this should be a regular practice. Today it's very basic quiz. As we progress, as per the content, you will be having the quiz based out on the topics covered. So that's how this will help you to revise and recollect the things learned.
Okay.
And any questions you have, like you are also join the DevOps community for all the updates. And for any queries, any technical queries, you can share the screenshots during the hands-on. You can share on the same number with the Mr. Raj. He can help you guide the queries. Or else you can share it in the WhatsApp group as well. Technical team, me or anyone from the team can help you.
But we are still not added in the WhatsApp group.
Yeah, registered students will be added to the group. It will be created in a couple of days by tomorrow end of the day. Until then, you can post the queries directly to him. He can share me those queries until tomorrow. All right, then. Thank you all for joining. See you tomorrow. Bye, everyone. Good day. Thank you all.
It is.